section 9.8 is factor completely. The first part is, let's look at this problem. This is where you are factoring out a common factor that is a binomial. This is what your previous problems looked like when we factored using the section where the a was not equal to 1. If you remember, they both have an x plus 5. We take that out, we're left with 4x minus 3. So it's kind of like the remaining steps of what we did in the previous section. Number 2, let's take 2b squared times b plus 6 plus 3 times b plus 6. They have a binomial factor of b plus 6. When you take that out, you're left with 2b squared plus 3, and that is factored. The next type is called factor by grouping. This is also like we have just done when a was not equal to 1, and we broke that middle term down. Let's take x cubed plus x squared plus 5x plus 5. The hint that you need to factor by grouping is there's more than 3 terms, so we can pair them up, this and this. We take out a common factor of each pair, that would be x squared. We would be left with x plus 1. Check it, that's x cubed plus x squared. Out of the second one, we can take out an 5. We would be left with x plus 1. Then you can see we're left with x plus 1, or have a common factor of x plus 1. We take that out, mark it out there, and you can see what's left, x squared plus 5. If you were to multiply that, check it by FOIL. Let's check this one. First, outers, inners, last, because these will not be like terms. They will not be added together. The first is x cubed. That's these two. There's 1 there. The outers are 5x. The inners are x squared. The last is 5. Now, if you just rewrite the order and put it in the order of decreasing exponents, x cubed plus x squared plus 5x plus 5. That's what the original problem is, and so it is factored correctly. We will also have what is called factor completely, which is always understood when it says factor. The word completely. So let's take 7x cubed plus 28x squared. Now the first thing I would look for is a common factor, or greatest common factor. They both have a 7. The two numbers have a GCF of 7. The variables have a GCF of x squared. If I take that out of each one, I'm taking the 7 out. I'm going to take 2 of the x's out, so I'm left with x. That gives me 7x cubed plus. If I take a 7 out, I have 4, and I took the x squared out. So if I remultiply that, 7x cubed plus 28x squared, that is the original problem, and nothing else can be factored completely. Let's do a couple more examples. Let's say we have 4m cubed minus 16m. They have, remember, the first thing is GCF, 4m. If I take that out, I'm left with m squared. I took the 4 out, I took 1m out. Then when you multiply that, you get 4m cubed. Minus, I took a 4 out, I'm left with 4, and I took the m out. Now, notice this is the difference of squares. So I have 4m, and that factors into the square root is m, the square root is 2. M plus 2, m minus 2. That is the final answer for factoring completely. Let's look at d cubed plus 4d squared plus 5d plus 20. There are 4 terms, so that gives me the hint that I factored them by grouping. So let's group the first 2 and the last 2, and let's see what is left. Out of these, I can take a d squared. I would be left with d plus 4. Let's check and make sure I did that correctly. D cubed plus 4d squared. That's what's there. These have a common factor of 5. They don't both have a d. If I take out the 5, I'm left with d. If I divide out a 5, I'm left with 4. That gives me 5d plus 20. Now you notice the common factor, the binomial of d plus 4, when you take that out, you're left with d squared plus 5. That is not anything that can be factored. First of all, 5 is not a square and it's not the difference. So that is your final answer. When you have a problem like this, negative 18x squared minus 60x minus 50, and we want to factor that. Since we're leading off with a negative, we want to take the negative out, and we need a GCF of all of these numbers, which is 18, 60, and 50. I'm going to divide each of these by 2. I get 9, 30, and 25. And these numbers don't share anything else, so I'm going to factor out a negative 2. I would get 9x squared plus 30x plus 25. Now let me just check that. That's negative 18x squared, that's negative 60x, and that's negative 50. Now, at first glance, this is a square, this is a square. So let's see, the square root is 3x, the square root is 5, and that's twice the product. Twice 15x is 30x, so that would factor into 3x plus 5 squared. And that's the way we would write that. Now, if we were solving these, we would simply have it set equal to 0. We would come down here and we would set the factor equal to 0. Let's look at an example to solve. So let's say we want to solve 4m squared minus 28m plus 49 equals 0. Now, at a first glance, this is a square. This is a perfect square. 2m, 7m, that's 14, doublet, 28. So this is 2m minus 7 squared equals 0. That's the way that factors. That trinomial is the square of a binomial. Remember how we recognize it? That's a perfect square, that's a perfect square. That is twice the product of those square roots. 14m, doublet, 28. With a negative, it means it's minus. Now, it's set equal to 0. That's both factors, so we only need to do it once. Set that equal to 0. Add 7. You get this. Divide by 2. You get this. Now, we could write that 3.5 or 3.5. but that's just solving. Remember, you factor using the different factoring we have learned in the chapter, and then you solve.